Okay, this is exam number 2 for fall 2010. Physics 101. The first problem says a soccer ball is kicked at an angle of 30 degrees, so theta is equal to 30 degrees. If the ball requires 1 second, t is 1 second, to reach the goal, what is its initial velocity? So this is our ball. It follows a path that looks something like this. The time is t equal 1 second. So the time to get up here is t equal a half a second, because it's half the it's half of the total time. So we just say that v is equal to v naught plus a times t. The velocity up here, this is all in the y direction, by the way. The velocity in the y direction at the top is equal to 0, so we have 0 is equal to v naught y plus a times t minus 9.8 times t, which is 0.5 seconds. And then I solve this for v naught y, which is equal to 1/2 times 9.8, which is 4.9 meters per second. But that's my y component, and that's equal to v naught times the sine of the angle, which is 30 degrees. And I solve this for v naught. It's 4.9 over the sine of 30, and that's equal to 9.8 meters per second, which is 10. So that's D. Which of these statements about projectile motion is true? The y component of the velocity is 0 at the top of the trajectory. Okay, that's true. Let's just look at these others. The acceleration in the y direction is 0. That is not true. It's not minus 9.8. The x component of the velocity is largest at the beginning of the motion. That's not true. It's constant throughout the entire motion. And the y component of the velocity is constant. That's not true. It changes. So the answer is A for 2. You drop a package from a plane flying at a constant speed in a straight line. Without air resistance, the package will remain vertically under the plane. You fire a projectile from a table, as in this figure, if the y displacement, this distance, is 1 meter, and the initial speed is 5 meters per second, so v naught is 5 meters per second, and of course the angle here is 0, so it makes it a bit easier. How far does the projectile travel in the x direction? So y, if we take y naught equals 0 up here, y is equal to minus 1 meters. First thing we're going to do is find the time, and we just say that y is equal to v naught y times t plus 1/2 ay t squared. This is equal to 0 because it's horizontal, and we have minus 1 equals 1/2 of minus 9.8 times t squared, and so t is equal to the square root of 1 over 4.9. which is 0.45 seconds. And then we want to know how far does it go. Well, it has an initial speed of 5 meters per second at a time of 4.45 seconds, so x is equal to v naught times t, which is 5 times 0.45, which is 2.3 meters. That is C for number 4. Which of these punts has the longest hang time? They all have the same height, so they all have the same hang time. D. This figure shows an inclined plane with a block. The block is accelerating up the inclined plane. There has the 3 forces labeled. Which of the following is an appropriate equation that follows? So I'm going to draw my axes. There's my y, there's my x. This angle then is 60 degrees. If I draw these again, there's my fn, there's my f. I'm going to write my x and y components of fw. This is fw sine of 60, and then this is fw cosine of 60. Alright, now let's see. fn minus f is equal to 0. That's not even an option, because fn and f are on different axes, so they're not related at all. fn minus fw sine 30 is equal to max. fn minus fw sine 30 is equal to max. Okay, that's wrong for several reasons. First, it has 30 degrees here. It should be 60, and this should be may, not max, so that's not an option. FW sine 60 is equal to Fn. Alright, there's our winner. We see that these forces are equal and opposite. Alright, so they're equal in that way. And then Fn is equal to Fw. That's not true. So the answer for number 6 is C. Okay, for number 27, so there's an elevator that's accelerating downward at 2 meters per second squared, and a 10 kilogram mass hangs by a rope inside the elevator. What is the tension in the rope? So let's label the forces. There's the tension, there's the force weight, and we just do the sum of the forces in the y direction is equal to the mass times the acceleration in the y direction. Sum of the forces is the tension minus the force weight, and that's equal to MAY. So we solve for our tension. It's just mass times acceleration in the y direction plus the force weight, and so that's equal to 10 times the acceleration, which is minus 2 because it's down, plus 10 times 9.8, that's 10, 7.8, which is 78 newton, which is 80 newtons. So the answer for this one is C. A dock worker loading crates on a ship finds that a 100 kilogram crate, that's the mass, it's initially at rest on a horizontal surface, requires a 400 newton horizontal force set it in motion, that's the static frictional force, and a horizontal force of 300 newtons is required to keep it moving at a constant speed, that is the kinetic force. We want to know what is the coefficient of kinetic friction, and we know that Fk is equal to mu k times the normal force, but here, since it's on a horizontal surface, the normal force is equal to the weight, which is mg. That's 100 times 9.8, that's 980 newtons. So mu k is equal to 300 over 980, 300, which is 0.3. So the answer for this one is A. Anti-lock brakes keep car wheels from locking up when you stop your car. Why does it help slow your car? Let's see, we know that static friction is better, and its mu s is bigger than mu k, so it must be D. That's number 9. D. A cart on a horizontal frictionless table. Once the car has been pushed and released, what will happen to it? It will continue at a constant velocity if there are no other forces acting on it, which is the case here. A block of mass m rests on the floor of an elevator that is accelerating upward at 12 meters per second squared. What is the relationship between the force due to gravity and the normal force? If it's accelerating upward, that means that the normal force is greater than the force of gravity. Let's see, you can see that if you just, if it's accelerating upward, A, this is the normal force, this is the weight, sum of the forces is N minus W equals MA, so N is equal to W plus MA. If A is positive, N is greater than W by the factor MA. This figure shows a cheerleader thrown up into the air. She reaches a maximum height of 6 meters. What is her initial speed? So we want to know what is her speed down here at the bottom. She only has kinetic energy at the bottom because the potential energy is equal to 0, and up at the top her kinetic energy is equal to 0, so she only has potential energy. Alright, so we want to set those two equal. That is that the potential energy at the top is equal to the kinetic energy at the bottom, and then we're going to solve for V. So this is mg times h is equal to 1/2 mv naught squared. Our masses cancel. We solve for V naught. Solving for V naught is the square root of 2gh. The square root of 2 times 9.8 times 6. That is 10.8 meters per second, which is 11. So that is A. 12 is A. Number 13, what is the speed when she goes through the hoop, which is at a height of 3 meters? So we can take her potential energy at the top plus the kinetic energy at the top, which we've already said goes to 0 because her speed is 0, and set that equal to the total energy when she goes through the hoop. So it's potential energy at the hoop plus the kinetic energy at the hoop. And then this is mg times 6 meters, and that's equal to mg times 3 meters plus 1/2 mv squared. Our masses all cancel, and then we're left with, let's see, bring the 3g over, 6g minus 3g is equal to 1/2 v squared. Multiply both sides by 2. That's 2 times 3 is 6g. Square root of 6g is equal to v. So that's 6 times 9.8. And then the square root of that is 7.7. So v is equal to 7.7 meters per second. That's D for 13. D is 13. Shopper in a supermarket pushes a cart with a force of 40 newtons directed at an angle of 60 degrees downward from the horizontal. Find the work done by the shopper as she moves down a 25 meter length of aisle. So work is just F D cosine theta. It's just simple plugging it in. The force is 40. The displacement is 25 times the cosine is 60. That's 40 times 25. The cosine is 60. It's 500 joules. That's B. 14 is B. 7 kilogram bowling ball moves at 2 meters per second. How fast must a 0.03 kilogram tennis ball move so that the two balls have the same kinetic energy? Well, kinetic energy of the bowling ball, you want to equal the kinetic energy of the tennis ball. This is 1/2 mv squared equals 1/2 mv squared. And we want to know what is VTB, the velocity of the tennis ball, or the speed of the tennis ball, so we solve it for that. See, our halves cancel. You can do this how you like. If you want to put in numbers, that's fine, but I'm just going to solve for VTB. So VTB is equal to the square root of the mass of the bowling ball, speed of the bowling ball squared, divided by the mass of the tennis ball. That's equal to the square root of 7 times 2 squared divided by 0.03 squared. So it's 28 divided by 0.03 squared, and then square root of that, oh goodness, 176 meters per second. That's not on there. Let me try it again. So 7 176 meters per second. I must have had a problem here. I'll fix it. So 176 meters per second. So 180 meters per second is the right answer. Okay, just a quick correction on number 7. I've done this before, so I'm coming back. This should not be squared, and this is not the right answer here. So this is equal to 31 meters per second, and that is option D. Box is being pulled across a rough floor at a constant speed. What can you say about the work done by friction? Well, friction generally does negative work, and that's the case here because the displacement is opposite the direction of the force. So it's A. A ball tied to a string is being whirled around in a circle. What can you say about the work being done by tension? That in this case the displacement and the force are at 90 degrees to one another, so tension does no work at all. Let's see. Car starts from rest and accelerates to 30 miles per hour. Later it gets on a highway and accelerates to 60 miles per hour, which takes more energy. Because energy is 1/2 mv squared, the bigger numbers, that means 60 squared minus 30 squared, is greater than 30 squared minus 0 squared. So it takes more energy to go to the higher speeds because of that square. If you look at energy, kinetic energy versus V, it looks like this. So you need more energy as V increases. Peter LaFleur throws a ball with a velocity of 10 meters per second. The mass of the ball is 0.5 kilogram. It strikes Dwight Goodman. What is the final velocity? So our initial momentum equals our final momentum. All right. Our initial momentum is just the momentum of the ball, and the ball had a mass of 0.5 kilograms, and Dwight Goodman has a mass of 100 kilograms, or excuse me, it has a velocity of 10 meters per second, and that's equal to the final momentum, which is just the velocity of White-Goodman, which is 100 kilograms times his velocity. So that's 50 over 100 equals his speed, or his velocity. That's 0.5 meters per second. That's D. Which of these best approximated by an inelastic collision? The collision of two cars is inelastic, and the collision between a baseball and bat. Remember, in this case, only momentum is conserved, not energy. So 1 and 3, that is C. Collection of particles has a total kinetic energy of 0. That means that their speed is 0. What can we say about the momentum of the system? Well, the momentum is 0 if the speed is 0. So the answer for 21 is C. The uranium nucleus is at rest and undergoes fission and splits into two fragments, one heavy and one light. Which of these statements is true? Let's see, the lighter fragment has more momentum. That's not true. They both have the same momentum. The heavier fragment has more momentum. Not true for the same reason. The lighter fragment has a higher speed than the heavier fragment. It has the same momentum, and since its mass is much smaller, its speed is bigger, so that is correct. And both particles have the same speed. That's not true. So 22 is C. A 0.5 kilogram football is thrown towards the east with a speed of 10 meters per second. A stationary receiver whose mass is 100 kilograms catches the ball and brings it to rest in 0.04 seconds. During this time period, what is the magnitude of the acceleration? Well, first we just want to know what is the force, delta P over delta T. Our change in momentum for the football, which is really all that we're concerned about, is Pf minus Pi over delta T, and its final momentum, it says it brings it to rest, is 0 minus, it's going to the east, so we'll call it positive mass times velocity. That's 0.5 kilograms times its velocity, which is 10 meters per second, over the time, which is 0.04 seconds. So our force is 0.05, and this is the force imparted on the football, is 5 divided by 0.04, which is 125 newtons, or minus 125 newtons. That means it's to the west, because the football is traveling to the east, so you have to impart the force to the west in order to stop it. But we really want to know the acceleration, so acceleration is F over m, and we just want to know the magnitude, so I'm going to drop the negative. 125 newtons over 0.5 kilograms, that's 250 meters per second squared. That's a pretty whopping acceleration. Complete this statement. A net force of 300 newtons acts on a 200 kilogram boulder, and a force of the same magnitude acts on a very small pebble. The rate of change of the boulder's momentum, that means what is delta P over delta T? Well, the force is same, so the rate of change of momentum is the same. That's A. Amy is 100 and Gwen is 50. They're standing on slippery ice and push off each other. Amy, this is Amy, and this is Gwen. Amy slides at 4 meters per second. So Amy is 3 times as big. That means that Gwen, who's 3 times as small, travels at 3 times the speed, so she travels at 12 meters per second. Oh wait, no, I'm sorry, 2 times. She's 2 times. So she travels at 8 meters per second. So the answer is B, and this is B.